the best way to learn these is just by doing lots and lots of examples. So let's do some examples. These are really simple examples. I'll make them a bit tougher as we go on, but I just want you to get the hang of how it works. Let's say we have x plus 2 equals 9, and I want to solve for x. Right, so I want x equals some number. Not any number, but the right answer. Right. First thing we're going to do is find the equal sign. And yep, there it is, right there. Next thing we're going to do is we're going to look at the right hand side. Do any of these terms have an x in them? Nope, they don't. We can just leave it. The left hand side has two terms. This one here and this one here. Do either of those not have an x in them? Yep, this one here does not have an x in it. So we want to bring this 2 from the left hand side over to the right hand side. And to do that we do the opposite. The opposite of adding 2 is to subtract 2, and whatever we do to one side we have to do to the other side for it to balance out. Now if we do our little accounting, the x is unchanged. 2 minus 2 is 0. 9 minus 2 is 7. And of course the plus 0 is redundant at this point, so our answer is x equals 7. If you had time you can test it. If we substitute 7 in there for x, does 7 plus 2 equal 9? Hopefully you didn't need a calculator. Yep, that's true. Again, this procedure is exactly the same as every single equation that you'll be solving. Break it down, divide and conquer. If that doesn't work, break it down some more, then divide and conquer. Okay, what about this one then? (3x minus 3 equals 12. Where's the equal sign? There's the equal sign. So that means everything on this left hand side must be the same, equal the same on the right hand side. Okay, on the right hand side, are any of these terms, do any of them have an x? 12, nope, there's no x there. Minus 3, nope, there's no x there. 3x, however, there is a 3, so we want to keep that there, and we want to get rid of this negative 3. We don't really want to get rid of it, we want to take it over the equal sign. So the opposite of subtracting 3 is adding 3. And whatever we do to one side, we always have to do to the other side. In a while we won't need to do this accounting step. 3x comes down, minus 3 plus 3 is 0. 12 plus 3 is 15. So we'll rewrite that. 3x equals 15. So far so good. Now there's one term here and it has an x in it, but remember 3x is the same as 3 times x, and I'm making the times a little smaller there, which is the same as x times 3. So the opposite of multiplying by 3 is to divide by 3. So 3x divided by 3, that's the whole thing has to be divided by 3, equals 15, and now the whole of the right hand side has to be divided by 3. These are going to cancel, they're not going to disappear again, they're just going to go to 1. And 15 divided by 3, if you know your times tables, that's 5. So x equals 5. Let's test it. X equals 5 up here. If we put this 5 where we had the x, do we get 12? Well, 3 times 5 minus 3, does that equal 12? Yeah, it does. This is pretty powerful stuff. This is what gets you to the moon. Okay, let's try one a little bit tougher. 2x plus 10 as an aeroplane comes over. It's a little Easter egg. Sounds like it's a turboprop of some sort. Okay, what do we do here? Well, same thing. We find the equal sign. There it is there. We bring everything which doesn't have an x on this side over by doing the opposite, and we want to take 10 away and take 10 away. So we do our little counting. 2x, so you can even think of it like 2x plus 10 minus 10 equals 2x, and on the right hand side, x plus 50 minus 10 is equal to x plus 40. Now what do we do? Well, there's no numbers on the left hand side, but there is this pesky x on the right hand side. In front of that x, even though it's not shown, it's implied that there is a plus there. So if I take an x away from that side and I take an x away from that side, I'm good. 2x minus x is 1x. X minus x is no x, and the 40 stays there. So we've actually solved it. We can rewrite this. X equals 40, and we're done. At that point, it meets our criteria. We have x by itself there equals some number, and I'll leave it to you to prove that that's correct.